Here we have 8-4, day 2. So the topic is still determinants. In particular, finding them, except we're going to up it here a little bit, and I'm going to show you how to do the 3x3, how to do a determinant. We'll do one of those from start to finish, and then on the last slide, I'll talk you through how to go about a 4x4. That will likely be an extra credit topic for Chapter 8. I would not expect that you would, it wouldn't be a test question that you'd have to do a 4x4. But should you choose to do it, I want to make sure that you're okay with, you've got the specifics of how to go about it. All right, so here's the formula for a 3x3. Okay, so just a reminder here that when you see an A11, A12, A13, that's the entry that's written in the matrix. Okay, those are the numbers across the top row. C11, C12, C13, those are cofactors. Okay, we talked about how to find those in day 1. Okay, and remember that for 1, 1 and 1, 3, okay, the minor is basically the same, well, it's exactly the same as the cofactor. Okay, it's this one right here, based on the pattern for the cofactors of a 3x3. We saw that you really just need to change its sign. That's all it really is. Before we dive into the 3x3, let's just quick brush up on a 2x2, because really, when you break down the 3x3, you're doing 3 2x2s is how you get the minors, and that's most of the work in doing it. Two times 3 minus 4 times -2, which would be 6 plus 8. That determinant would be 14. Okay? Again, that's the 2x2. Now let's jump over and do start to finish a 3x3. All right, so here it is. We're going to find the determinant of this 3x3. And here's, it's got a couple steps to it, so here's how I would recommend to organize your work. I would say start with the biggest step, that we have 3 minors that we need to get. Okay. Remember the label for those minors if you take out that row and that column. So for 1, 1, it's going to be 2 times 6 minus 3 times -6. If I take out 1, 2, that will be 3 times 6 minus -1 times -6. And if you take out row 1 and column 3, you would get 3 times 3 minus -1 times 2. Okay? See, that first one ends up being 12 plus 18, so our first minor is 30. The second one would be 18 minus 6, or 12. And then we'd have 9 plus 2, which is 11. Now this next part, I'll write it out just because this is in your notes and you're going to refer to it. I'm going to write out the cofactors ahead of plugging them into the formula. I don't really care if you do this step or not, but I think it's important that you could refer to it in your notes. Cofactor 1, 1 is 30. And for a 3x3, this is really the only thing, is cofactor 1, 2 goes from 12 and then switches over to -12. And cofactor 1, 3 just stays at 11. Okay? And at this point, we are pretty much ready to go. We're going to get the determinant of B. Okay, so in that formula, when you saw A11, that's 3. Okay, that's the entry that's in row 1, column 1. That needs to be multiplied by cofactor 1, 1. Negative 2 needs to be multiplied by negative 12. Negative 2 is coming from there. And then last but not least, the entry in row 1, column 3 is 8. That needs to get multiplied by 11. We've got our numbers plugged into our formula. We number crunch that. That's the easy part. You just throw it all into a calculator. And we get 202, which we haven't seen a determinant like that before, but we did cover in the first day that determinants can vary dramatically. They can be 0, they can be negative, they can be positive. It depends on the entries that are in the matrix and how big it is. They can be pretty big. And here we see it's, I think the biggest determinant we'd seen was like 14 or 16 or something, and here's one that's over 200. Okay, so let me give you, if this is something that you would want to take on, and I put an extra credit topic on the test to do a 4x4, let me just take you through how you would do this. If you're not interested in this extra credit topic and you're like, the 3x3 case is plenty for me, you could, honestly, you could stop watching at this point and call it good. Here's what's going on. Same type of formula. Okay, so the determinant of A would be A11 times C11, entry times cofactor, entry times cofactor, and of course we have a fourth. Okay. Now remember that the cofactors are based off of a pattern where the minors may change signs. Here's the patterns for a 4x4. It goes plus minus, plus minus. You really don't need the rest of these because we tend to stick with row 1. So in terms of changing sign, what it really means is that cofactor 1, 2, when you find that minor, you would change its sign, and cofactor 1, 4, you would have to change its sign. Okay? Now you might be seeing this and thinking, really? That's not so bad. Okay? That's not so bad. So remember how, and the process is really similar. Here's where it really becomes an extra credit topic. So for each of your cofactors, okay, because if you relate it to the 3x3, we had to break it down with our minors and do 3 2x2s. So think if I take out row 1, column 1, that's going to be my first minor. That's going to be M11. That's where it gets a little bit crazy, is you have to do 4 3x3s. In the example previously, we did 1. Okay, you have to do 4 of those. In a 3x3, those minors were reduced down to 2x2s, and remember, we love the 2x2 case. It's quick, it's easy, it's simple, it's wonderful. Little bit different story with the 4x4. So here, 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 and here, each one of those represent a determinant of a 3x3 matrix that you would need to find. Okay? If you know the 3x3 case, you can do it. It's just, it takes a lot of steps, and that's why it's going to be an extra credit topic.